All right, class, welcome to section 1.3 of Pre-Calculus 20. Today we're going to look at geometric sequences, and we haven't really talked about what they are yet. So first of all, let's talk about what a geometric sequence is, and then we'll apply to it a formula, just like we did with arithmetic. So a geometric sequence, if you're interested in writing down the definition, is a sequence where the ratio of consecutive terms is constant. In the arithmetic sequence, the common difference was present. Here we have a constant ratio, and we usually call it the common ratio, and we will be using the letter R to represent it. So if there's a common ratio, that means there is a common multiplier to get from one term to the next. So as you look at these five, see if you can pause the video and figure out which five are geometric sequences. So now that you've had a chance to look at them, which of them are, I will reveal the answers. There are three that have a common ratio. If you look at the first one, the common ratio is 2, or 2 over 1. It's being doubled every time. Similarly here, the common ratio is 2, or 2 over 1. And here, what is the common ratio? You might not have figured that out. Well, to find your common ratio, and this is an important thing you can write down, simply take term 2 and divide it by term 1, or term 3 and divide it by term 2. It doesn't matter which. In this case, that would be 80 divided by 100, which is 0.8, or if you reduce the fraction, 4/5. That would be the common ratio. So the form, or the formula that we're going to use is written right here. It's sometimes also, I would normally write it with an A instead of the T1, but it's the same difference. The first term times the common ratio to the power of n minus 1. So you can see I've already revealed the answer for this geometric sequence, which would be -2. See if you can, again, pause the video. What is the common ratio for the next three? All right, now that you've tried that, let me show you the answers. Where did they come from? Point 2 is term 2 divided by term 1. 0.5, term 2 divided by term 1. Same thing here. 8 divided by 2 is 4. Now the general term is what you would get when you replace your A value with A. Your T1, your first term, would be 4 times your common ratio to the power n minus 1. And you can see that that's the answer. Again, try yourself. Fill in the other three. Okay, now that you've tried it, here are the answers. Just replacing the first term with the first term value from over here. So we've got 100 and 100 and 80 and 80 and 2 and 2. And then we've got our common ratio. Simply goes in the brackets to the power of n minus 1. So you're going to find this to be very similar to what we've done so far. Just it's geometric rather than arithmetic. So let's take a look at this example. She's enlarging by a factor of 110% each time, and the length of the image is 150 pixels. What would the length be after 4 enlargements? So the fourth term of the sequence is the first term multiplied by the ratio of 110%. As a decimal is 1.10. And this will be the fourth, so 4 minus 1. So we end up with 150 times 1.10 to the power 3. So we need to this is a calculator question. So I would get out a calculator here. If it will let me, it's not showing up, so I will just grab my calculator and figure that out. 150 times 1.10 to the power 3. And I got 199.65. And because this is a problem, to include a unit. That's it. You'll get your assignment next time you're in class, and we'll get some practice at this. See you then.